index laws that I'm sure you've seen many, many times before. First of all, law number 1. If you are multiplying things that have the same bases, all you have to do is add the powers. That's the m plus n, right? Multiplying with same bases, add the powers. That's law number 1. Law number 2. If we are dividing things with the same bases, we subtract the powers. Do these rules ring a bell? Yes? No? A little bit? Good? Okay, they make more sense when you actually see them in proper questions rather than these formulas with m's and n's in them. Law number 3. When you have something to the power of 0, it is always, always, always equal to 1. Anything to the power of 0 is equal to 1. That's a great law, that one. Law number 4, if you have brackets where you have a power both in the brackets and outside the brackets, you need to multiply those powers together, which is a to the power of m times n. There, law number 4. Law number 5 is kind of an extension on that. If I have got 2 things inside the bracket, then each of them need to be to that power outside of the bracket. So a to the power of m and b to the power of m if you were to expand those out. And law number 6 is also very similar. It still works if it's a fraction. Everything inside has to be to that power of m. So it's a to the power of m and the b to the power of m to expand out those brackets. So those are our 6 basic index laws. There's going to be some other ones coming later that involve, oh, don't growl, okay. That involve negative powers and other things, okay, and fraction powers. Examples. Number 1, using the appropriate index law, we want to find out what a cubed times a to the power of 5 is. We are multiplying, we have the same bases, so all we have to do is add those powers. Don't change your base. So a stays the base. 3 plus 5 makes 8. Easy. Yep, done. Part B, if there are numbers out the front, you multiply those normally. So 3 times 2 is 6. And then just do each base letter separately. So I have a base of m where I have 2 here and another 5. Add those powers. 2 plus 5 is 7. M to the power of 7. Then do the n's. N to the power of 5 and n to the power of 4. N is the base. 5 plus 4 is 9. We still good? Yes, great. Question 2 is law number 2. We are now dividing. So as long as we have the same bases, k is my base for this first one, I subtract the powers. 12 take away 4 is 8. Okay, there's always like an easy example and then a slightly harder one. In the second one, we have numbers involved, and unfortunately 15, you can't divide 5 by 15. It doesn't go very nicely. 15 divides by 5, but not the other way around, right? So what you need to do is make that into a fraction and do the cancelling method. So 5x cubed y to the 9 on the top, and on the bottom 15x y to the power of 5. Okay, so then my numbers out the front, both of them can divide by 5, giving a 1, and 15 divided by 5 is a 3. Then I can cancel my letters. Now, the line means divide, so I am going to be subtracting the powers. The x on the bottom has a power of 1, right? There's no number there. Remember, it's a 1. And so I do 3, take away that 1, would mean that I would have 2 left on the top. Yeah, cancelling the 1 off means take 1 off that top one. Same with the y's. I can subtract those 5 off the 9. 9 take away 5 means there'd be 4 left on the top. Okay, once we've done all the cancelling, we write down what's left. Very carefully, so we don't want to miss anything. We have a 1, but I don't need to write that because I have an x squared y to the power of 4 on the top. And on the bottom, all my letters are gone, but there was the number 3 still there. Yeah? So that's law 2. Question 3 is law number 3 with the powers of 0. Yes. Remember that anything to the power of 0 is always equal to 1. But just be careful that you correctly identify what is to the power of 0. Not everything in this question is to the power of 0, only the A is. The 3 is sitting out the front. So sometimes it's a good idea, when you're a little bit uncertain, to circle the part that's to the power of 0 and go, that's going to be equal to a 1. Okay? So I really just have 3 times by 1, which means that that's just equal to 3. In part B, the slightly harder version, let's do the same thing. We'll circle the parts that are to the power of 0. So m is to the power of 0. That's going to be equal to 1. That whole bracket, all of that is to the power of 0. So that's going to be equal to 1. Let's write down what's left. I still have the 5 out the front, which means 5 times 1, plus that big bracket on the end is also becoming a 1. 5 times 1 is 5, plus 1 is 6. Yeah? Great. Question 4 are the ones involving all the brackets. So, this one, if you've got a power inside and outside of the brackets, you multiply those numbers together. So m is the base, 3 times 5 is 15. If there is a number inside your bracket, like B here, that means that that number has to be raised to the power of whatever's out here. So that needs to be 3 squared. That does not mean 3 times 2. What is 3 squared? 9. Okay? So that will become 9. Then for the letters, we times those powers together. So it's only the powers that you times. The big numbers out the front has to be to the power of, as in you use the power button on your calculator if you want to. So 5 times 2 is 10. All right, last one. We've got numbers out the front. We've got letters on the top and the bottom. Lots of fun things in there. So everything inside has to be to the power of 3. Starting with the 2. 2 to the power of 3 is? No. Who? Someone? 9. No, not 9. 8. Okay, check on your calculators, all right? So you got to go 2 to the power of 3. It means 2 times 2 times 2, or 2 cubed, that's right, which is 8. All right, so 8 for that first number. Then I have an A, and the powers I have to multiply. 3 times 3 is 9. Now for the bottom. The big number out the front has to be to the power of 3. 3 to the power of 3 is? 8. Nope. Stop guessing. 27. Use your calculator. 3 to the power of 3 is 27. Okay? The B is the base. Multiplying the powers, 2 times 3 is, what did you say? 6. I thought you said 9.
No, I said 9.
Yeah. It's a 6. That's it. That's your index laws that we're practicing today in 2F. Easy.
Okay.